In 1977, the Voyager 1 spacecraft was launched to study worlds beyond our solar system. The two Voyager spacecraft have become the longest operating missions in the history of space exploration. After 48 years, Voyager 1 is now traveling about 25.4 billion kilometers away from Earth, moving at a speed of roughly 61,000 kilometers per hour. Although Voyager 1 is the farthest human-made object from Earth, we are still able to communicate with it continuously. But before we eventually lose communication with the spacecraft, how far can it actually go? To answer this, we first need to understand how Voyager 1, located about 25.4 billion kilometers away, receives and sends data. From Earth, a 20-kilowatt signal is transmitted to Voyager via radio waves. It takes about 23 hours for this signal to reach the spacecraft. Voyager receives it using an extremely sensitive antenna. For comparison, a rover on Mars typically takes about 15 minutes to send a message back to Earth. After receiving the command, Voyager uses a 20-watt signal to transmit data back to Earth. As this signal travels through space, it gradually weakens, and by the time it reaches Earth, it is so faint that it is almost impossible to detect. When communicating with objects at such vast distances, the most important factor is not the power of the transmitted signal, but having receivers sensitive enough to detect extremely weak signals. For this purpose, NASA uses the Deep Space Network, DSN. The DSN consists of 3 antenna complexes placed at roughly equal distances around the Earth. Each complex includes one massive 70-meter antenna and several 34-meter antennas. By combining these antennas, the network can detect signals thousands of times weaker than a typical FM radio signal. The Deep Space Network dedicates hours every day to listening for the faint signals coming from Voyager 1. So far, the spacecraft continues to communicate with us. Over the past 50 years, our methods of detecting signals have improved significantly. As a result, with current technology, there is effectively no strict limit to how far we can communicate in space. In fact, it is theoretically possible to communicate reliably, even with objects located light years away, as long as we have receivers sensitive and accurate enough to detect those extremely weak signals. So how far can Voyager 1 go? As Voyager 1 travels farther and farther from Earth, the time required to send and receive signals increases, the signal strength decreases, and data transmission rates become slower. This makes communication with the spacecraft increasingly difficult. Voyager 1 itself will continue its journey through space indefinitely. However, even though our technology allows communication over vast distances, our connection with Voyager 1 will likely last only a few more years. Voyager 1 is powered by nuclear energy, and its electrical power supply is gradually weakening. To conserve power, engineers disabled the spacecraft's camera in 1990 after it captured the famous pale blue dot image, showing Earth as a tiny blue speck in the darkness of space. Today, out of the 11 scientific instruments originally on board Voyager 1, only about 4 remain operational. These instruments are used to collect data on magnetic fields, solar wind, and cosmic rays beyond our solar system. The end of Voyager is approaching. In about 2 more years, Voyager 1's power supply will be completely depleted, making it impossible to operate its instruments. Scientists will continue attempting to communicate with the spacecraft. Eventually, it will transmit its final bits of data and then fall silent forever, disappearing quietly into the darkness of space. So, the end of the Voyager missions is near. Yet we can take pride in the incredible journey they made and the invaluable scientific knowledge they gave us. Thank you very much for watching the video. Subscribe to our channel. See you in the next one.
The truth is rarely what it seems.